Welcome again. So, shall we continue with Karolina's lecture? The floor is yours.
Thank you. So today's main talk would be on the quality of the observations. I made it together with Halfdan, who has prepared quite a nice case study that I will present you in the end of the talk. The outline of it is so. I will define you, tell you about what is the nature of the problem, what is an automatic quality assurance system, and give you an overview how does it work in Belgium. And the last thing would be analyze of this a case of one station in Iceland. The measurement devices that you have on your station can cause different types of problems, and the errors that they provide can lead to wrong assessments if we want to compare the measurements, or if we just want to base our conclusions on these measurements. So it's very important to identify the sensors that don't work well, and or the periods of observations that where the sensors didn't go well. So the observations that can't be trusted. Some of the sources of the problem could be that, for example, a measurement device stopped working for some reason, battery is off, memory was full, or the attachment of the cables is not proper, someone made mistake, some reason. We can also have wrongly calibrated devices, so the output range that the measurement device produces is not the one that would reflect the real state of the process that it's measuring. For some reason, the sensor can get stuck, like in northern countries. It's for icing, when the ice is building, for example, around the wind sensor, so it cannot move around to see what is the wind direction. Another source is lightning activity, when you can have the sensor stuck for some time. How can we spot the problem? The first, most basic way of assuring if our measurements do well is to see if the values fall within their assumed range. So if we don't have too high oversaturation, or if we have a wind speed that is below 0, or things like that. Another one is, do the observation vary with time? So do we have the same values stored for each timestamp, or do we have variations? But on the other hand, don't we have too large spikes in data? Another is, do we have some missing values from the time series? So, for example, we have a set of devices that measure different components of the weather, and we have suddenly an value, an empty value for one of the measurements. So this is some sources of problem that can appear in a single. Sorry. Yeah. That are the problems that can be seen on the observations. Another important issue, if you have a network of observations, is trying to figure out if the observations from the neighboring sites look similar, or do they different too much. The first way, you should start with your assessment of the quality would most probably be the manual inspection. So you just look at the data series and try to understand if this data series is appropriate based on your knowledge and on the data, also on your expert knowledge and on what are the presumed values in your part of the world. However, you can improve your subjective assessment that you make by manual inspection with some automatic procedures that will help you spotting out the problems and do some first marking of your of the problems that you have in your network, or you may also think it as sufficient for your observations. We are using the quality assurance system that was presented in Mark Schaffer's paper from '99. The paper is called Quality Assurance Procedure in the Oklahoma Network. And this quality assurance bases on performing 4 quality tests on daily portions of data and assign them one of 6 quality measures. That means that if we have a time series of several variables, such as wind speed, wind direction, temperature, humidity, for a set of stations, then for each station, each variable, and each timestamp. So for a single measurement value, you will have 4 tests, and you can have one of the 6 results for each of these 4 tests. The quality checks the 4 quality checks that are within the system are range check, step check, persistent check, and spatial check. I will go through them now. So the range check is to compare each datum that you have with the typical value range that you would expect for your value. So it checks, as I said, if you don't have an oversaturation, or you don't have the wind below 0, or your temperature is not 500 degrees. You can also compare with some typical values for your region. So do all the variables fall within their ranges? And if it finds an error here, it stops testing. Yes? Sorry. Okay. So the step check verifies if our time series is continuous, or do we have some missing data in between, such as like periods of missing data or single variables that are missing, and aren't they too large, because maybe for some